Hello 8th graders, this is lesson 5 in our module 1. We are moving along in our exponential forms, exponential notation. And today we are learning about negative exponents. And we are applying all the laws of exponents that we learned so far. So before we get to those negative exponents and what they mean, first we are going to spend 2 days on this lesson. So before day 2, you can stop the video and resume it at different day, or you can just continue on and get it all done. So we are going to start with examples. I'm going to take a little piece of paper here and let's write 123 in exponential notation, so expanded form in exponential notation. So we have 100 plus 20 plus 3. How can I write that in exponential notation? So I have 1 times 10 to the second power, because that's how we have 100. It's 10 times 10. Then we have plus 20, which is 2 times 10 to the first power. And then we have plus 3. In our lesson 4, we learned that any number times 1 is itself, so 10 to the 0th power is 1. Okay, so we know how to write a whole number, expanded form of a whole number written in exponential notation. But how would I do 123 and let's say 123 thousandths written in exponential notation? Can we do that? We can continue the pattern. So I had, and already here I will just repeat, 1 times 10 to the second power plus 2 times 10 to the first power plus 3 times 10 to the 0th power plus. So now we have tenths places, hundredths places, thousandths place. So how can I expand that? I have 1/10, I have 2 hundredths, and I have 3 hundredths. 1/10, 2 hundredths, and 3 hundredths. Sorry if it's too small here. How can I write that in exponential notation? I can continue the pattern. C210, what happens after that? We are going to the negative side of our number line. So we will have 1 times 10 to the negative first. I have plus 2 times 10 to the negative second. And I have plus 3 times 10 to the negative third. Negative second, hundredths place. Negative third, thousandths place. And I wrote thousands. Does that mean that I have a number that is written with a negative exponent being a negative number? No, because we just proved that this is a fraction. 1/10, 200, 3 thousandths. These are written in exponential notation with a negative exponent. So negative exponent does not, by any means, mean that it is a negative number. Negative exponent means that it's just simply a fraction. So let's look at it a little bit closer. What is that negative exponent? First of all, let's think about what is, so let's take a number, 5 to the second power. 5 to the second power is a number that we already know. 5 multiplied by itself 2 times. We know that this is a repeated multiplication. Exponent shows us repeated multiplication. So if I have, what is the opposite of multiplying? And I know that 5 to the second power is 5 times 5, and that is 25, right? Okay, so to get 5 to the negative second power, we are going to do exactly the opposite. What is the opposite? So exactly opposite. So what is opposite of multiply? Divide. Opposite of multiply. Multiplication is division. Opposite of multiplication is division. When we and also opposite of a negative number, right? What is opposite of a negative? Opposite of negative is positive. Okay, so we are doing exactly opposite. We are doing opposite of a negative, and we are doing opposite of multiplied by itself. So we are going to divide by itself. Let's look at dividing by 5, right? So if we are going to divide by 5, we need to look at what is that division? What is that multiply? When we divide by something, divide by a number means what? From the 7th grade, you know, when we divide fractions, we have to multiply by the reciprocal. We learned that many times. You repeated it so many times in 7th grade. So when we divide by a number, we multiply instead by the reciprocal. Okay, so when I'm dividing by 5, I'm really multiplying by the reciprocal of 5. What's the reciprocal of 5? 1/5, right? So when I have 5 to negative second, I really am multiplying by the reciprocal. Instead of dividing, I'm going to use multiplication. And I'm multiplying now by the 5 taken by itself twice. So it really is multiplying by the reciprocal. 1/5 times 1/5. Okay? And that is 1 to the, divide by the 5th to the 2nd power. This is our rule right here. 5 to the negative 2nd means 1/5 to the 2nd. We will move on to our rules in a minute. But right now, I just want you to understand how that thing works. So let's try a couple different problems here. Let's say 3 to the negative 3rd power. 3 to the negative 3rd. 3 to the negative 3rd, it means I'm multiplying 3 by itself 3 times. When I have 3 to the negative, I'm using opposite of that multiplication. So I'm really dividing by 3 times. So it's kind of a divide by 3, and again divide by 3, and again divide by 3, right? I'm dividing by 3 times. Now, when I'm dividing by 3, I'm really multiplying by the reciprocal. So times 1/3 times 1/3 times 1/3. That means I have 1/3 to the 3rd power. So 3 to the negative 3rd is 1/3 to the 3rd. Okay? It's a fraction. It's not a negative number, it's a fraction. The negative exponent shows the reciprocal of a number, not a negative one. Okay? Let's take 5 to the negative seventh. 5 to the negative 7th. Negative exponent is not a negative number, it's a fraction. It's 1 over 5 to the 7th. 1 over 5 to the 7th. It's like I'm multiplying by the reciprocal of 5 7 times. Okay? Let's take 8 to the negative 4th, and that is going to be 1 over 8 to the 4th. 100 to the negative 5th is the same as 1 over 100 to the 5th. Okay? Let's get to our rule and the exercises. So when our rule states for any non-zero number x, so x cannot be 0 because we cannot divide by 0, and for any positive integer n, we define x to the negative nth power is the same as 1 over x to the nth power. That means it's just a reciprocal of x to the negative nth. Reciprocal is 1 over the number, right? Note that this definition of negative exponent says x to the negative 1 is just the reciprocal, 1 over x to the first power, or of x. Okay, so let's get to our exercises here. Again, reciprocals, not negative numbers. So 5 to the negative third is the reciprocal of 5 taken to the third power. Exercise 2. Okay, this one's interesting. It's 1 over 8 to the 9th. This is a fraction, so how can I change that? It will be 8 to the negative 9, because we just learned that we are going to use reciprocals, and this is, I'm doing just the opposite. I have the reciprocal of a number, and I need to use the opposite. So it will be 8 to the negative 9. Okay, so our next one, exercise 3. I have 3 times 2 to the negative 4th. How can I write 2 to the negative 4th? Easier. I'm going to use the reciprocal, 1 over 2 to the 4th. And now I can write 3 over 1, right? And I can actually multiply the numerators. So I will have 3 times 1 is 3, and 1 times 2 to the 4th is itself. So I get 3 over 2 to the 4th. 3 times 2 to negative 4th is 3 over 2 to the 4th. Exercise 4. X to the negative third is the same as 1 over x to the third. Exercise 5. Let x be a non-zero number. So 1 over x to the 9th. This is a reciprocal of a number, so we need to change it into a regular number. So x to the negative 9th. Notice how when we are bringing a number over that division sign, we are changing the sign of the reciprocal. That will help you a lot sometime soon. Exercise 6, x, y to the negative 4th. Just like in the exercise 3, we are going to just place that negative and use the reciprocal of it. So you will have x times 1 over y to the 4th. And since x over 1, I can multiply the exponents and just simplify it down even more. X over y to the 4th. X times y to the negative 4th is x over y to the 4th. Okay, so now let's look at that exponential notation of an expanded form. I have 4 and 728 thousandths, and I need to write it in exponential notation. I'm going to turn the page over and rewrite that number. I have 4 and 728,000. 728 thousandths. Okay, so I have 4, which is 4 whole numbers. It's not hundreds, it's not thousands, it's just 4. It means 4 times 10 to the 0th power, because it's just 4. 4 times 1. 4 times 1 is a 4. Plus, now we have decimal numbers. Decimal numbers are the same as fractions. Fractions are the same as reciprocals. So we are going to use 7 times 10 to the negative first, because if I put 10 to the negative first, I will have 1 over 10 to the first, which is 1 over 10 to the first, and 7 tenths is just exactly what that is, 7 tenths, right? Plus 2 times 10 to negative second. 2 times 10 to negative second is 2 times 1 over 10 to the second, which is 2 times 2 over 10 to the second, which is 2 hundredths, right? Plus 8 times 10 to the negative third, and that is going to be 8 over 10 to the third, which is 8 thousandths. Okay. Exercise 8. 3 times 10 to negative fifth. We have, and we need to use the value. We need to find the value of it. So what can I do to find that out? I know 10 to the negative fifth is the reciprocal. I'm going to use the reciprocal, 3 times 1 over 10 to the fifth, right? And I can multiply 3 by 1. I will have 3 over 10 to the fifth, and 10 to the fifth is 1 with 10 with 5 zeros, 4, 5, which is 100 thousandths. How can I write 300 thousandths as a decimal? 0 and 10th, 100 thousandths, 10 thousandths, 100 thousandths, 300 thousandths. Okay, let's look at 3 times 10 to negative second. It's the same as 3 over 1 times 1 over 10 to the second, according to our rule, which is 3 over 10 to the second, which is 3. 10 times itself is 100. 3 hundredths is 0 and 3 hundredths. Second number after the decimal. Exercise 10. This is a challenging one. I'm going to give you a try. I'm going to have you try it on your own, and if you get it, great. If you don't worry about it. That's a challenge. Okay. We are at day 2. You can now pause the video and return to it tomorrow or the next day whenever you feel like it. Make sure it's not too late. And we will continue then. All right, so we are in day 2 of lesson 5. We accept that for non-zero numbers x and y and all integers m and n, and we are just reviewing our formulas. X to the mth times x to the nth is the same as multiplying numbers with the same base, different exponents. We are adding the exponents. X to the mth power risen to the nth power is the same as a number with multiplied powers, m times n. If I have a product of numbers, x times y taken to a power is the same as I'm applying that power to every member of that product, every factor of that product. X y to the nth is x to the nth times y to the nth. We also learned that x to the mth over x to the nth is a division problem with the same base, different exponents, so we subtract the exponents. X to the m minus nth power. And when we divide two different numbers with taken to an exponent, we can take the numerator and raise it to the same exponent, and denominator and raise it to the exponent. Okay, so we continue exercising these. We are taking all of them together and practicing. So we also learned that any number to the 0th power is 1, and we learned that any number to the negative power is the same as 1 over that same base to the positive same power. It's a reciprocal of a number. Okay, so let's apply all of that we know here. Exercise 11. 19 to the power of 2 divided by 19 to the power of 5. We have the same base. So what do we do with exponents? Subtract it. So we will have 19 to the power of 2 minus 5. 2 minus 5 is negative 3. So it will be 19 to negative 3rd power. How can I write a positive number? Well, it's all positive number, but how can I write it with the positive exponent? Using a reciprocal. 1 over 19 to the 3rd power. Exercise 12. 17 to the 16th power divided by 17 to the negative 3rd power. I have the same base, so all I'm doing is subtracting exponents. 17, and look at it very carefully. I have now 16 minus, and I'm subtracting negative 3. So I will actually have double negative here. I'm taking away negative 3. 16 take away negative 3. Since I'm taking away negative, I'm actually adding, right? Subtract a negative means add the opposite, add positive. So it will be 17 to the power of 16 plus 3, and that is 17 to the 19th power. Okay, number 13. If we let b equal negative 1 in number 11, a be any integer, and y be any non-zero number, what do we get? I'm not sure I'm understanding this question, so I'm going just to skip it. I think something is missing here. B negative 1 in exercise 11, and we don't have that here. So I'm sure it was related to a different problem and we just skipped it. So I'm going to skip exercise 13, don't worry about that one. And this one we need to show directly that 7 to negative 4th, 7/5 to negative 4th is 7 to negative 4th over 5 to negative 4th. So let's look at this way. And this will be a little bit challenging. So if you like challenge, this is one for you. So we have 7/5 to the negative 4th power, which is, I'm going to write right here in this place, 7/5 to the negative 4th. And I'm going to use the reciprocal, just like I learned in the previous lessons. It means that I'm dividing 1 by 7/5 to the positive 4th power. Now I'm looking at 1 over 7 to the 4th power over 5 to the 4th power. Okay? And now when I am having 1 over, that's the reciprocal of a number, right? So we can turn it back to that number, which is going to be 7 to negative 4th over 5 to negative 4th. And that's how we prove it. This is challenging, so that's okay if you don't understand it. The rest of it is the problem set, and I wish you good luck on that one. We are going to check it in class, and we are going to do some more practice problems of applying rules of exponents in all different ways. I will see you in class.